Okay, question 5. There's quite a bit of thinking that we need to do for this one. Okay, so it's a collision. So as soon as you see the word collision, you should be thinking principle of conservation of momentum, which is the total initial momentum is equal to the total final momentum, right? Now initially, the ball's got a mass m, right? So initially it's m times u, okay, which is the mass times the initial velocity of that ball, and then we need to add to that, okay, the momentum of the stationary ball. Oh, but it's stationary, so the velocity is 0, so that term just disappears. Okay, and then we've got to look at the final momentum, right? So the two masses are going to join together and move off together. So that means that they're going to have their total mass is going to be 4, and then they're going to have a common velocity. I'm going to call that v. All right. So with a little bit of mathematics, okay, we've got mu equals 4mv, which means that we can cancel the m's, and I can see that u is going to be equal to 4 times v, or v is going to be equal to u over 4. Right, so that's our first important result. Then we've got to deal with the next bit, which is all about kinetic energy, right? So let's compare the kinetic energy initially with the kinetic energy finally. So initially, we've just got a half mu squared, like that, easy, right? How about finally? Okay, we're going to have half times by the mass. Now the mass is going to be 4m, all right? And then it's v squared, right? Okay, but over here we've just worked out v in terms of u, so we can substitute that into there. So I've got half times by 4 m, and then it's all of that squared. Okay, so it's going to be u over 4 all squared. Okay. So one of those on the bottom there cancels with that 4 there, and blah blah blah. So what we're going to have? We're going to have a half mu squared all divided by 4. Okay. So now we can compare this one here with this one here. All right, and you can see that the final kinetic energy is just a quarter of the initial kinetic energy, all right? And for that to be the case, we must have lost 75% of the kinetic energy. So D, 75%, is the correct answer.